So next up, we have Professor Pankaj Jalote, who is from IIIT Delhi. He'll be discussing the integration of open source in software engineering education. He'll share insights on the popular course at IIIT Delhi that teaches students to develop applications using open source software and methodologies. This course emphasizes on real-world practices like GitHub use, project management, OSS tools, preparing students for modern software ecosystem. Please welcome Professor Pankaj Jalote.
Thank you very much. Thanks to the organizers for inviting me for this. Very different from what we've been hearing, and I was curious to learn more about what is happening in the Indian FOSS community, because generally speaking, in literature, what has been written, papers that have been written, are about FOSS, well-known open source software which have been developed elsewhere. So I was keen to know, and I'm very pleasantly surprised at the energy there and the good projects. I've been sitting through most of the talks, and there's been very, very good. So I'm very happy and impressed about what is happening and taking back some knowledge of my own. So in any case, I will just share something very different, not about practice, which is, but about how we can use open source in educating for software engineering. It's not about just adopting open source software, Linux, databases, this, that. That's one aspect, that's the easy aspect. But can we incorporate open source into education of software engineering itself? So that's the idea. But let me still, though I'm sure all of you know about the background of open source, but many of you are very young, so you may not also. But open source, many of you may not know, it started actually with Unix. When I was a student, people used to just share code on email, right? Or on this thing. So it started really then. And then in 80s, as you would know, the Richard Stallman, who's really could be called the father of open source, started at MIT, started this Free Software Foundation, which then evolved into a platform that we now call open source, which then became FOSS, right? So that's what we have. So though earlier it started with was focused on developers producing solutions for developers. So editors, languages, stuff like that, operating systems. But now, of course, we see that there's a lot of applications there. In the morning itself, we heard about applications being developed for end user use. So it has changed over quite a lot. And we know that now open source is actually used by most of the businesses. So it is actually completely prevalent. And it's no longer a fringe phenomenon, that some people working on it. Adoption of open source, use of open source, and participation in open source is pretty much part of the software ecosystem, very important and integral part of the open system, right? So currently so open source, by the way, when it started, it was almost all volunteers. Now, when the businesses have gotten into it, very serious way, more contributors in open source are paid now than, for example, when 80s, 90s, when open source started. So there has been a change in culture also. All right. So now coming to what do you do? How do you inject open source in software engineering education? Right. Now this is a bit of a challenge because any education in a university or a college focuses first and foremost, it must focus on fundamentals and principles and concepts, and then you can have projects and you can apply things. But the education is about uncovering concepts or and making sure that students understand that. So therefore, how do you incorporate that? And that's where we have to realize, which I'm sure all of you do, being practicing this open source personnel, that open source has provided not just the software, but the open source methodologies and practices are also quite different from what traditionally they used to be. They're also sound, of course, has been shown by such a variety of open source software that has been produced of extremely high quality. So by the way, there's been some studies which have shown that open source software is of the same quality as commercial or paid software. So once you can, and these processes and practices, so researchers have studied many open source projects and books have been written, papers, there's lots of papers about it. They have extracted these, and once those principles become available, now you have a vehicle to actually inject it into a teaching this thing, which is what the course in IIIT Delhi does. And the goal of the course is really kind of this thing is to enable the student through this course to develop the skills and knowledge that is needed to develop a modest size application in a small team while employing open source software as well as practices. Right? That's how the course has evolved. Okay, just I'm sure many of you use it, but this may be slightly, from what I've been hearing, I think the practices in open source communities and are changing. But nonetheless, there are some practices which we have to recognize when you're teaching it. Most open source projects historically don't do requirements, typically. They don't do SRS or requirement specification. Some initial architecture, but even that is not there. Typically, workers are volunteers, so they're not part of a team managed by some team leader who assigns work. So the volunteers choose work. So it's a very different kind of model. The team itself is dynamically, loosely organized, self-organizing of developers, users, and others. And this is probably one of the few models which fundamentally assumes geographically distributed teams. Okay, it does not assume, it has many practices of Agile, but Agile fundamentally assumes a small co-located team, while open source actually assumes a distributed team, which means most communication is through electronic means. Okay. So few practices that have worked for large software, open source. Personal commitment is really one of the driving or one of the unique features of open source, unlike code being produced in a company where you are working because it's a job and so you have to perform. In open source projects, at least the traditional ones, and even the ones that I heard today about, the people come because they have a personal commitment to the project or to the cause of the project. So that makes it kind of different from what it is there, what the dynamics of development and so on. Okay, typically there's a small core team. So this again, studies have shown of multiple open source projects. Typically there's a small core team of 10, 15 people. And around the core team, there is a bigger team which will help the open source project. So often 80% of the code is done by these small core team, and then there is a whole bunch of people who will fix bugs, raise issues, and do some other stuff. Okay, so that I just mentioned a few. So these are the kinds of things which are providing you some base to introduce it into in education. Now you can look at what are the projects that have been open source projects that are successful. What is it that makes them successful? I think the talk before lunch also talked about that, nice insights there. But typically most open source projects will start with a working prototype and a promise. I think today morning somebody mentioned about it's a promise. What you're promising is what is more attractive than what currently is. And so you may have a prototype, but the more important thing is the promise. And whoever is leading an open source project should have an ability to attract others, to form a community. If you don't, then you are a good technical person who happens to be using an open source platform to develop your software. That does not make it an open source sort of software or a product. And the development coordinator therefore needs to know how to lead without a title, without being designated as a manager who can assign work. So without coercion, without the power of that comes with that. Okay, so one general rule of thumb. Some of you would have read this book about a book as well as a paper, The Cathedral and the Bazaar, which is really one of the most famous works on open source. And there are some other papers as well. But really speaking, in open source project, the core group is their small core group. You have 10 times as many people who are developers in the group but are fixing bugs or UI or what have you, and yet another bigger user group. Once you have that, you have a successful open source project going. Core group, a bunch of other people who are helping the core group develop, and 10 times as many people who are using it and part of user community, not just using it, but part of user community who are attached to the project. All right, so these are some characteristics of open source projects. All right, now let's come to the software engineering course that we teach. In most computer science curricula, there would be a software engineering course. It tends to be a very hard course to teach because software engineering itself has become very big. I mean, you have every little topic has articles, has books, has you know what. Okay, and how do you design a course? It depends on what's your goal of the course. What do you want the students to learn as a result of that course, right? Let me just show some which you might relate to whenever you were a student. So sometimes the course is taught in a manner where the goal is that the students understand the concepts relating to software engineering, life cycle testing, this, that. Okay? Which is only knowledge but no skills. Okay. So what do I need to do something? Oh, okay. So this is actually very common in India, unfortunately. It's highly unsatisfactory as a software engineering course. You can have a goal where students learn how to write good quality code, do rigorous testing. You know, that is a better goal. I've seen some courses where they do that, but it's really still a programming course with testing added to it. The best form of a course can be where the student develop the ability to execute a project end to end. Okay, so starting from some users to delivering a usable software to the users. If you can do that, that would be a good outcome, and it's very challenging to teach, but we can take this outcome and convert it to something where open source is to be used. So we know there is a huge repository of open source components, there are libraries, there are frameworks, all of them are available. Okay, so, and we know that no software is written today from scratch. You always use all these other artifacts that are available. Okay, so one way you can have inject software engineering in open source is that the goal becomes that students will develop the application, as I said, writing minimal code. So that's a twist that you bring. The goal is not to show that you can write big amounts of code, but the goal is to show that you can develop a big application writing minimal code. Okay, there are other aspects of it because, as we know, managing code, etc., is much more challenging. If you can reduce the footprint of your own developed code, then that code base gets far more manageable, far easier to handle, and so on. So you ought to leverage the code bases that exist, which over the years have been proven to be very reliable, very high quality, highly optimized in terms of performance and so on. All right, so therefore you start using open source tech stacks, libraries and frameworks, and of course, and you use open source processes except in cases of education, it's co-located teams. But by the way, I should mention that there are many places across the world which have actually even gotten the co-located teams out. They collaborate and their teams may be geographically distributed. But at least the way I work with it is still co-located teams within the institute. Okay, so the main challenges, I'll just mention two and then just share something. And I think, so first of all, whenever you want the students to have an experience and learning of a full life cycle project, a semester is just 4.5 months long. You have a challenge. You have to almost start the project sort of day one. Okay, that's a bit of an issue because you haven't yet taught anything and yet you want the project to start. But there are ways to manage this, by some pre-reading and various other ways. But you really have to start the project very early in the game so the students have a time to do one iteration, maybe another iteration, and you can have some acceptance testing and some other kinds of stuff that you can do. Okay, and of course, this is if you want the students to learn this, the project has to carry significant amount of weight, and not just the code part of it. As I said, the goal should not be how big the code is. The goal is how rich your functionality is and how you have leveraged what you've got. So you have to look at assessment of not just the code, but also the quality, the test scripts that have been written, the architecture that was used, etc., etc. So assessment gets kind of tricky, but you have to do that. Okay, the biggest challenge comes, how do you get a realistic project? If you give one project and everyone does this, that's no longer real. That's again a contrived toy problem, right? And students know that. Okay, so a couple of things I worked with is that keep the team size small. 3 is a good size because that allows people to work together and yet freeloaders are sort of avoided. And I just encourage well before 2 weeks, 3 weeks before that you go and find a sponsor for a project. So you go and find whatever, if your own company, your father's company, or brother's this thing, or your school, you find somebody who wants to sponsor a project and at least in principle is willing to deploy the software, that application that you may develop. I also get within the institute a bunch of them. And the third thing is allowed, they can join an open source project. So that's the other way they can do their project, right? Okay. So at least one time, I also reached up to startups that, hey, look, if you want to guide a project, you can probably get 1 or 2 teams to do something useful for them. Startups are starved for funds and talent, so they are in some senses a natural fit that they can possibly get some of them. Okay, so just to mention, many of these projects have actually resulted in software that continued to get used after modification, after the course was done. So typically in courses you do demonstration, you demonstrate what is to be done, and then that piece of software is thrown away. Okay, last 2 years ago or 1.5 years ago when I taught, by then LLMs had already come. Okay, and LLMs we know is a powerful tool for engineers, and every engineer will be using it. So there is no need, or you have to leverage it. Just like you have to leverage the open source, it exists. You should leverage it to build better software. You should leverage LLM also to build better software. So clearly, once you incorporated open source in your teaching, with this approach, this also makes sense to incorporate. So finally, I incorporated this also. The course got extended that students were fully empowered to and encouraged to use LLM in their project. So the goal still remains, you write minimal code. You can either take existing code from open source or generate code using LLM. The goal is to build a rich application with as little effort as you can. So it's some sort of difference about it. So just to summarize, So software development, we know across the world, has changed considerably. It's just that in teaching, we never really changed it much because we like to talk about fundamentals and so on. So for a long time, teaching remained the same. But now we know that since open source is an integral part, it would be good to integrate at least in the course of software engineering something about open source. So this is a possible approach that I've this thing as to with the goal of developing the ability to build a full application using open source technology stacks and frameworks and libraries and open source software as well, open source practices as well as LLM as a tool. So it's fairly challenging to teach, but students truly develop advanced knowledge and later on they tell you how useful it has been for them, not just because they're doing in a job, etc. That is fine, but they're also in their own this thing, if they're doing their own startup something. And just to let you know, I had written a book long back on software engineering textbook. It's fairly often used. So then based on this experience, I've revised it. So this is probably a tentative one for India. And the Springer, which originally published the global edition, will be also publishing it. But I think one of the reasons I want to point out, I've already stated it in the book, that the royalties from the book will be given to open source projects or student clubs or for student education. Okay, so if you can motivate your teachers in using it, it will help promote. You're no longer students, but you probably know teachers, and to promote the use of open source software in a richer manner, not just use Linux, use this database, use that way, but in a richer way you can promote the use of open source to at least improve the teaching of software engineering. All right, that's all I have. And if there's time, I think we have time for questions. Yes, sir. Yeah.
Great talk, Dr. Jalote. It's quite some time since the second edition came. It's been almost more than, I think, 30 years that you actually, because we remember reading it, the book that time, and this was the go-to book on software engineering. But one of the things I wanted to know is that your course program that you have made in an 8-semester course, where do you think software engineering really fits in? Because if I compare it with other engineering disciplines, for example, mechanical engineering, civil, or others, the design aspects are actually taught in the first few semesters and then students use it. I feel that software engineering, I don't know, I'm not a computer science major, but I think it's coming very, very late in the course curriculum, by which time students are already they're doing their toy projects, they're doing their programming and things like that. I have personally feel that I think those skills per se, it may not be in a formal course, but starting from the first time when they start to learn programming, they need to actually be cognizant of the whole idea of software development per se, at least the basics like what code commits require to be, version control, how do we do testing, and all those sort of basics need to be imparted to students even before they really start building things. And then you can go and tell them that, okay, these are larger things. So what are your thoughts on that, sir?
A completely good point, and it would be nice if it can be done. That is, some basics introduced early while they are learning programming and doing their toy projects, and then build the rest of it this thing. Except that the way curriculums come out, you need then two placeholders. So often doesn't work out, right? So the way curriculum designers, you're teaching database, you're teaching operating system, and then there is a course on software engineering. And anything in teaching in this, you must realize it can only be meaningfully taught to students who are reasonably proficient programmers. Otherwise, this course doesn't make any sense, right? This course is not meant to teach students programming. You ought to be quite proficient programmer. This is about building software systems, assuming that you are already a decent programmer. So therefore, some amount of background preparation is needed before you should do it. But yes, I agree, it would be nice if during that preparation, some concepts are introduced and injected. That would be very nice.
I think open source at that level can actually help that more by getting that open source
Hello, Professor. Thank you so much for the talk. The reason I'm even asking question is because this is something that's very close to my heart as well. I've been working for the past 12 years, and I wish we had a course in parallel with our academia that will teach us what to expect in the real world, right? So I have a slight deviation from the gentleman here's thoughts, right? Because introducing such concepts early on might overwhelm the students with, like the corners of software development as opposed to learning the building blocks which we are given right now in our academia. What I do propose though is, perhaps you're already following it, is in every subject that we learn, there should be a real world component associated with it. Like a war stories, like compiler design you're learning, what happens actually when you build a compiler in C in the industry at Red Hat, for example. Or if you're learning about microprocessors, what happens at Intel? If you're learning about software engineering, what happens in a small startup or in a mid-sized company or in a large-scale company? Such war stories, like in other operating system textbooks, they should be accompanying the core curriculum as well, is my take on it. But obviously, this has to happen from small colleges to at scale, right? So that's just my thoughts.
So good point, but let me just, since you yourself use the word adding too much can overwhelm, in the same spirit, when the student is just learning compilers, you don't want to overwhelm the student. They should learn grammar, how to parse it, how to code generate, etc., etc. And they must learn how all this theory translates into practice. And then if there is still room, you can talk about that. Okay? And all good places I know, for example, compiler course, would make sure that the students actually write a compiler. Okay? And that itself doesn't leave any room to talk about how compiler is developed by NVIDIA. This itself is going way beyond, you're pushing the limits everywhere. Right?
Right.
So, yeah, but I understand your point. But we have to keep how much can the student absorb? Pushing too much onto the student doesn't help learning. You just push things on to the student.
So in the course that you're talking about using open source to explain, one of the things I notice is how do you differentiate between software development? Because when you give projects to folks and you're asking them write as less code as needed but build something, that focuses more on the business side of things. On, hey, coding is there is open source libraries available. How can I solve a problem? How can I get a project out without coding? That implies more of a business learning that could help. How do you differentiate that?
No, please. So, and by the way, you give any individual problem, unless it is already tailored, as it turns out, there's still enough code to be there despite using all the code available to you. So hardly any problem comes ready-made that you get it. So it's not business, it's about solving problems. The smart way always of solving problems is to use existing solutions to solve new problems, right? That's always been the engineer's way. It's just that, it's trying to formalize a little bit of what has already been there. So it is not going into the business, it's not talking about whether this would be a good product or anything. Just says there is somebody, so the startup guy comes and says, I want this software done. As far as this course is concerned, we are not looking at, is it a good idea? Will it have users? Will it have business? No, it's a software problem. Or rather, it's a problem to build a software solution to solve some stated problem, which may or may not have business.
So, question.
Yeah, please.
Is this like a graded course?
Excuse me, I think we are over time.
Out of time?
Okay.
You can ask the questions afterwards. Okay.
All right. Thank you very much. Thanks a lot.